Hey, welcome to another lecture for programming in Python. Um, Today we're going to be talking about what I would generally refer to as lists, but what is more referred to in a more general word as collections, which are groups of data. So far in the class we've talked about integers and floats and strings, and we always treat these as a variable that just has one piece of information attached to it. Right, the value of variable 1 is 1, and then you set it, and now it's 2. But when you start working with really large amounts of data, you often want to refer to a bunch of different values as sort of a combined object, and that's where you start to see the usefulness of collections. So in older programming languages like C, originally there was only one collection type. These are called arrays. And the basic idea is you can have an array of numbers, just like you have a variable that is one number, so variable 1, and it has a value of 5. An array of numbers also gets a name, so it's called, you could say variable 2. But instead of just having one value, it has as many values as you tell it to have. So in C, you had to define an array with a set number of values. So your array of integers would contain, if you chose, 5 values. So it stored 5 different integers. This was really important in older languages, because the computer had to know how much memory to give this new variable that you defined. Where we talked about earlier in the data types lecture, variable 1 being an integer has a very specific amount of memory that it holds. And so you could imagine that if you then start putting this into an array, it's an array of integers, and you need to know that it's 5 integers so that the computer knows to allocate the amount of space and memory that it needs to store 5 integers. From there, once you've defined this group of objects, you can set the values of those 5 integers just like you would a variable. Fast forward a little bit, we find that Python does have a type that is sort of directly analogous to an array, but they also have a number of other ways to group data together. In fact, there are 4 default ways to group data together in Python. The most direct analogy to the older way of how these things, of how arrays were defined in C, is with what's called a tuple. So in order to define a tuple, what we do is we say, let's say var1, I'm going to start programming here, equals, and then for a tuple, we use a parentheses. And then in order to define your tuple, like what data is inside of your tuple, let's start with doing numbers, because it's always easier in programming, I think, to do numbers. 1, 5, 10. So now Python reads this line and says variable 1, oh, it's a variable. And what is its value? These parentheses indicate that to Python, this is going to be a tuple. And it's going to be a tuple that has 3 entries in it, 1, 5, and 10. So now how do we get Python to give us back one of those values? So let's say var, let's say print. And you know that if you defined var1 originally, var1, and printed this, what would it do if you had defined this as just a number? It would just print that number. So let's see what Python does for that first, for just printing the basic variable. You'll see that for just printing var1, Python is smart enough to try to print you back the whole list. And that's fine, but if you had, say, 10 million numbers in your array, or rather in your tuple, you generally don't want to print your whole tuple out. So instead, what you want to do is point to some place in this tuple. In order to do that, you use brackets. So in how I've written this here, you say print variable1, but you're not just printing variable1, you're printing some part of variable1, and these brackets tell you what part you're printing. Tuples, just like old-fashioned C-type arrays, are indexed. So you have to tell it which one to print, and the index counts from 0. Everybody in this course will mess up the fact that indices count from 0. It just happens to everybody programming. Try to remember it. It'll pop up and get you somewhere. But so what I'm doing here is asking Python to open this variable and grab the value at index 1. And if we look back at variable 1, counting from 0, 0 is this value, 1 is 5, and 2 is 10. So when I print here, what I expect it to give me back is 5. And lo and behold, that's what happens. Okay, so that's fine. Now what if we want to change this? var1 at 1, so let's pull that back out, that variable that we just printed, equals, let's name it, let's change it to 6. Okay, now if we try to print var1, what will we see? Or var1 at 1, we get an error. Why? Well, the interesting thing about tuples that makes them slightly different from C arrays is that tuples are what's called, they are unchangeable. And that may seem really useless. And that's because it is very useless. Most of the time you want to be able to change the values in your list as you go, update things, add more, remove some. Tuples are extremely rigid, and in fact they're more rigid than C-type arrays were. C-type arrays you could assign to, you could change the values within them, you just couldn't change their size because you needed to know how much memory. And that essentially, that all of that, you might ask why, what's the point of that? It boils down to the fact that tuples being more rigid, they're actually assigned they're an even more precise amount of memory than what they were assigned in C. And it makes them very, very efficient. So tuples are generally something that you only use when you really, really know what you're doing, when you have a static, unchanging set that you need to reference, and it will run faster than other collection types that we'll talk about in a moment. You will see these very frequently because people who are very good, if you look at other people's code, people who are very good at code use a lot of tuples because, lo and behold, if you know exactly what you're doing and you've coded well, you can optimize things much better with tuples than you can with other types. But all that being said, a tuple is a collection of objects that have an index and you can't change them. Pretty easy. So what are our other types? I said there are 4 types of collections. They essentially boil down to tweaking these properties, right? Order, whether or not they have an order to them, whether or not they're changeable, and whether or not they allow duplicates. I would prefer that you can break them down by those properties, but I would prefer you to understand these types by a use case, by a sort of optimization argument. So our second type is what's called a list, and this immediately addresses one of the issues that I pointed out a moment ago. And I actually have a reference up for syntax for these because I always get them mixed up. So never hurts. Let's define a new variable var2, and with a list, instead of using a parentheses to define it, we use brackets, square brackets. So let's try this with the same set of information as var1. And in fact, I'm going to extend var1 a little bit further just to give us a little bit more entries to play with. I'm going to add a 20 and 50. So var2 now is a list defined with the same entries as var1. So let's see what happens if we print the first entry in var2. Lo and behold, we have 5 again. Okay, that's awesome. But what sets a list apart from tuples is that, unlike tuples, lists are changeable. You can actually you can change a lot about a tuple. So now let's see what happens. var2 of 5, or sorry, var2 of 1 equals 6. And now let's again print var2 of 1. And voila, we've changed this entry. var2 at 1 is now 6. This is more similar to how a C array functions. But just to make it a little bit confusing, it can't be the same as a C array. So let's look at this, an additional property that we get in Python for lists that we don't see in C-type arrays. And that's being able to change their size, right? I told you at the start, the reason why we have to define these things with a set number of numbers in them is so that the computer knows how to allocate the amount of memory. Python, being a interpreted code, has a lot more flexibility on how it can reallocate memory in real time. So Python is smart enough to be able to say variable 2 needs this much data attached to it, and then we can tell it, actually, variable 2 needs to be a little bit bigger. And Python can figure out how it needs to scoot things around to make that possible. So on that note, let's add another index to var2. So var2 dot pop, or rather push, is push, if I remember. 100. Let's see if I get this right. Print. And even though I have a code reference up, it can only help you so much. And this is why we need 1, 2, 3, 4, 5. This is why we still need actual developers and not AI to write all our code. No push. All right, let's remind ourselves what the syntax for adding list items is. Oops, it's append. Just like working with the text files we did before, append means to add something. So just like we are appending to a text file, we are appending a thing onto the end of this array, rather this list. And there we go. Now we have a 5th entry in var2. That is 100. Okay, so you can append. You can also remove items from a list with the remove function. You can sort it. You can insert items. There's a lot you can do. You'll have to for the assignments that we get, you'll have to look up the methods for them and give them some tries, and I'll try to give you some problems that really justify why certain methods exist. But for now, just know that the thing that makes a list is that it is a group of numbers or strings or whatever you want it to be that has an order and the indices, and you can change it. You can change the values, you can change the size, you can change a lot about it over time. Okay, so we have a really rigid set of objects that are in a group. We have a really sort of flexible set of objects that are in a group. You might ask, okay, so what else can we do? The first and most useful one, in my opinion, that is other than the list and tuples, I'm sort of going by what I find most useful in these. The next most useful thing, in my opinion, is what's called a dictionary. And just like a real life dictionary, what does it do? It gives you a definition from an index. So in a dictionary, a normal book dictionary, you say, you open it up and you say, what is an apple? And you go and you look, you have a single small word, apple, and you go and find apple. And then what is apple? It has a piece of data that's associated with it, right? An apple is a fruit that comes from an apple tree, right? Like there's a bigger piece of data and sort of a search, a thing that identifies that piece of data. So, with that in mind, what do we think a dictionary would be? It is like a list in that it is a group of objects that have identifiers, but instead of identifying our individual objects with a number, right, var2 of 1 equaled 6, you can identify it with a more general piece of data. Usually what you see is people use words, right? It's a dictionary. So in order to define a dictionary, you define it similarly, but you don't get to, with a list, you got to define it with just a number and a comma and a number and a comma. But with a dictionary, you have to both tell it how to identify the object and the object, right? You have to tell it apple is this definition. And you can't just assume that, like with a list, where you could assume your key was an index that goes from 0, 1, 2, 3. You can't do the same thing with a dictionary. So in order to define a dictionary, we will do, I'm going to say var3 equals curly brackets. And then instead of just defining the entries outright, let's do apple, and you use a colon to tell it. So this is our key, right? It's the same. It's sort of the same thing as an index in the other collection types, but we can make it whatever we want, so we call it a key now. And then value. So you can make your values a string, you can make them a number. Let's just be simple and make it a number right now. And then we add a comma, and then we say, all right, baseball is 5. Actually, let's do some fun. Let's do alpha and bravo. So we'll use military style numbering, and we'll correlate it. Alpha is 1. Bravo is 5. Charlie. So is 10. I don't remember military numbering beyond that. So just to show what we're talking about, now we have a dictionary. So instead of 1, 5, and 10 being identified by 0, 1, and 2, we get to pick how they're identified. So 1, 5, and 10 in this case are identified by Alpha, Bravo, and Charlie. So if I want to get 5 out like the other times, I will take var 3, and I have to give it the key, Bravo, which is the same as our 1 index from before. So if we play, we see, we get down, we print the new appended value, and then we print the var 3 of Bravo, and it's 5. So success, it works. A lot of people will immediately say, like, oh, well, it seems like dictionaries make way more sense to me mentally, so we could just use dictionaries for everything. Just like tuples being more rigid and therefore faster than a list, dictionaries have more freedom and are therefore generally slower than a list or a tuple. This doesn't always hold true for dictionaries. There are some dictionaries have a weird way of scaling to very large amounts of data. With really large amounts of data, if you are sort of dumb in how you search your list, a dictionary can be faster than a list. But in general, the more freedom you get, the easier these collections are to work with, the slower they are. So usually, if you can find a faster way to, or rather, if you can find a way to use the more static, harder to use data types, you will have a program that performs quicker. So with all that being said, you've seen how 3 of these work. The last one is one that I have very seldom used, and it is called a set, var 4. So it is defined like, and you can see I rarely use it because, there we go. A set, unlike is, let's see, it's kind of in a weird place between a list and a tuple. A set allows you to, I got an extra bracket. A set allows you to define a group of things, but unlike a list or a tuple, you can't, it's unordered. You can't refer back to a specific object in a set. So you can't say var 4 of 1 equals 5, because it doesn't have an order. It sort of just mangles all these together in memory and then has functions to look at what's inside. And just like a tuple, it is unchangeable. So once you've defined it, it's a group of objects that you that has values, but you can't refer to any particular value, and you can't change the values once they're inside. Mostly what this is done for is essentially having a group of things and then later checking if it contains a a certain sub value, right? So like you could say, does my var4 contain 5, but you can't get much else. You can't change that value, and you also don't know exactly where that value is stored in it. This seems really useless, and it is kind of. It's kind of the. It's a weird intermediate between all three of the other data types, and in that, because of that reason, personally, I've never found a good use case for them. I'm sure there are places where they are extremely well optimized to run uh, things, but I've never had a piece of code where I needed a set. Um, but as this is kind of class, it's good to know that they exist. Yeah, so that is sort of the four basic types. From here, there's a lot to learn about each of them. Each of these types has its own set of methods that you can use to work with it. And uh, the more familiar you become with the methods on a single type, so more familiar you are with the list methods, the more comfortable you'll be using it, and the better you'll be at using it. But uh, you know, take that, be cautious with that, because as you need to learn to use them all, because you'll see them pop up places, maybe with the exception of sets, but you should still know how to work with it. And uh, learning to get good with these is pretty much a learning to use the set of associated functions with each of them. So I only showed you a couple functions for each of these data types. And if you go to Python documentation, you can look at all of the associated functions for each of these data types and get an idea of the types of things that you might do with them. And you'll see some of the things you'll need to do with them in some of the homework assignments. And you get, actually, in the next set of, you'll notice that I rearranged some of the lectures that were on the syllabus, because we will immediately start working with lists, and lists and tuples and dictionaries, and we're going to work with them pretty consistently to the end of the semester. And you'll understand why a little better next lecture. But good luck, and don't get overwhelmed, because the collections are where you really can start to get into data. You're talking about groups of data, what's going on with individual values and things like that. This is where you're really going to start getting into the tools of the data world. All right, have a good day, and have a good night too, I guess.